All right, today we're looking at lesson 4.3. We're going to analyze a visual model for polynomial multiplication. So we're going to start with task 1, and let's look and see what we have. A binomial is the polynomial with two terms. You can represent a product of two binomials as the area of a rectangle with the binomials as side lengths. You can then find the product by breaking the rectangle into smaller rectangles. The area models below show that. All right, so the original rectangle here is x plus 4, and this side length would be x plus 2. And you can see the area of a rectangle is length times width. So that's where the x plus 4 times x plus 2 comes in. And since we're learning to multiply polynomials, this is what we're going to do first, is look at a visual model. All right, so what they're saying is you can break this large rectangle into 4 smaller rectangles. So if you do that, the top side is x plus 4, and they just break this into x and then 4 smaller pieces, and then this is x and this is 2, so it's going to be a smaller piece as well. So here you've got x times x, and that produces this x squared, and then this side times this side, x times 4 gives you this, 4x, and then this side length times 2 gives you this, and then the 4 times 2 gives you the 8. So they're taking, like, this side length would be 2, and this would be 4, since it's on the edge. All right, so the area is x squared plus 2x plus 4x plus 8. And then if you combine your like terms, you get the 6x in the middle. So as you guys have done multiplying before, you've multiplied binomials, so you know you do x times x is x squared, and x times 2, which is 2x, and 4 times x, which is 4x, and then 4 times 2, which is 8. And you can see that combine these gives you that, and these two expressions are equal. So all they did was take the large rectangle, write it as smaller parts to an equivalent rectangle. All right, to find the product of 3 expressions that are binomials or monomials, you can use a volume model instead of an area model. So remember, volume, the difference is it's 3-dimensional. The first diagram below represents the product x plus 3 times x plus 2 times x, as shown in the rectangular prism with dimensions x plus 3, x plus 2, and x. The second diagram shows the prism subdivided into 4 smaller prisms. So this is the same concept as above. It's just a 3-dimensional shape instead. So it's a little bit harder to visualize, but that's what we're going to do. So your volume is length times width times height, and so that's why you've got the 3 side lengths. So we're going to say this side is x plus 3, this one is x plus 2, and the height is x. All right, so we got the same thing over here. They put it a little bit smaller so that they could put extra information here on the side. So they've made this corner here volume 1. So volume 1, and then they've made the green section here in the back volume 2, and then this section is volume 3, and this purple section here volume 4. So let's see what the question says. It says determine the volume of each prism. All right, the volume of V1 of the blue prism is, all right, so this is x, and we need to know what the height is. You can see right here, the height right here is x, and the length here on the back, like this inside area, I'm saying back, but it's kind of in the middle, this is also x. So you should be able to see that that larger rectangle is x times x times x. That's the blue one. And then we want to do the volume of the green prism. That's the one in the back. So we know this side is x. So that means you've got an x here. We also know it's got a side length of 2, and it's also got a height of x. They're all going to have a height of x. So it's going to be x times 2 times x. And then the third one, volume 3, is the orange one here. So it's got a 3 as one side, an x as another side, and then a height of x as well. So x times 3 times x. And then volume 4 is here in the back. Nope, it's the purple one here. So this side length is 3. It's got a side length of 2 and a height of x. So 3, 2, and x. So what we're doing is just breaking that into smaller sections so that you can see the volume there. All right, it says, which of the following represents the volume of the original prism as a polynomial in standard form? All right, so if we want to find the volume in standard form, then we would take the x plus 3, the x plus 2, and the x, and we're going to multiply that together. Okay, so that's the volume. So x times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. All right, once we combine like terms, then we still have one more x to bring in. So let's go ahead and add like terms first. So I've got x squared plus 2 plus 3 is 5x plus 6. And now we have to distribute this last side length, or x. So x squared times x is x cubed. So plus 5x squared, and then plus 6x. All right, so that comes from multiplying the length, the width, and the height. All right, so if we go back down to this question, it says, which of the following represents the volume of the original prism? All right, so the volume would be x cubed plus 5x squared plus 6x. So that would be the one in the middle. All right, and it says find the product by repeatedly applying the distributive property and using the order of operations. All right, so we've done that. All right, so x times x plus 2, that's what we did in the beginning, the first two steps, and then 3 times this product here is this, and then we still had this on the outside. So that would be step 1. And then step 2 would be this step here. And then step 3 would be combining the x's in the middle. And then step 4 would be this one. I'm surprised I did that exactly like they did it, because there are different ways to do that. You could have multiplied the x first, but I started with the two binomials. So that is how you would find the product. And if you have any questions, please let me know. We're on lesson 4.3, task 2, multiply polynomials. All right, so you can see that you can use the product of power property and the distributive property to multiply polynomials. The table shows how to find several types of polynomial products. All right, remember the power product is one of your exponent properties. We did a lot with exponents last year in Math 2, so hopefully that is familiar. If not, you definitely need to review properties of exponents. All right, to multiply two monomials with a single variable, all right, you're going to multiply the numbers, and you're going to have the same base. You add the exponents, okay? Multiply coefficients and add exponents. Two monomials with multiple variables, you multiply the numbers, and then the same variable, you add the exponents. So a to the third and a to the sixth becomes a to the ninth, b to the fourth and b squared becomes b to the sixth. So multiply coefficients and add exponents of like variables. When you multiply two binomials, you're doing distributive property. So you do x times the second binomial and then 3 times the x, or the second binomial. So again, same thing. When you have same variable, you add exponents. So 2, and then when there's no number or exponent there, you assume it to be a 1. So 1 plus 1 is x squared. And then here you've got 3 times 2x is 6x, and 3 times -1, -3. So this is just distributive property. So it says use the distributive property to multiply each term in the second binomial by each term in the first binomial. All right, it says you can expand the techniques described to find binomials, including trinomials. A trinomial is a polynomial with 3 terms. Cam and Jacob use 2 different methods to find the product. All right, Cam's method. So first he puts it in standard form, both polynomials in standard form. That way, when he gets to the end, it's already in standard form. So that just is very helpful. All right, then, so it says write each polynomial in standard form and align the polynomials on, I don't know if part of that's missing or what. Multiply by 7 for each time, and then multiply by x for each, and then combine like terms. All right, so for this top row here, it was 7 times 2x, 7 times x, and 7 times 4. That's where this first row came from, multiplying 7 by everything in the top row. Then the second row here, this row right here, came from multiplying x by each term in the first polynomial. And then you just combine like terms. There's only one cubed term, so you bring it down. 14 plus 1 makes 15x squared. 7 minus 4 is 3x, and then bring down your 28. So this is called the vertical method again, because you stacked them up vertically before you multiplied. All right, the second method, horizontal method, again, put it in standard form first. This kind of helps you have it in standard form when you finish. So you're going to do x times everything in the second polynomial, and then you're going to do 7 times each term in the second polynomial. All right, so we did do this last year as well. So please look through that and then just kind of see that it doesn't matter which method you use, you're going to get the same answer regardless. All right, it says, how is Cam's method similar to the vertical method for multiplying whole numbers? All right, so if you multiply whole numbers instead of polynomials, you still multiply by each thing on top, by each number in that column. So that's very similar to just multiplying with numbers without variables. Which method do you prefer? Again, that's an individual thing. It doesn't matter. I think I prefer the horizontal method just because that's what I've always done. I don't think I've used the vertical method very much for multiplying polynomials, but again, whatever you prefer, it should work to get the same answer. If you have any questions, please let me know.